Hi everyone. So let's dive into a little bit more kind of technical, and I will just give a short presentation on the capabilities of the Freeton blockchain and how it's all structured and what kind of tools it has. And you can, yeah, I planned it like for really short, and then I will hand over to Katya and Boris, who are leading the tools for developers tools inside Ton.Labs, and they can talk more in depth about these tools and how to use them, and how to write smart contracts in Freeton. So if you will have any question, just drop in the middle, whatever. And so I will just give an overview. So the Freeton blockchain is the latest generation blockchain. It's quite unique also if you compare that with others of these kind of generation blockchains. And that what we regard this current generation, the latest generation blockchains are really just, I would give several names. Maybe you heard of them. It's Solana, Near, Polkadot, and more or less that's it. There are some others also, but they're like much smaller, and also I don't really know if they work. So if you compare Freeton with these blockchains, okay, so Polkadot is a blockchain which is a sharded blockchain. Okay, so it has let's call it Masterchain, and then they have what they call parachains, which are something that you can create your own blockchain, and then you do something on this blockchain as you wish. You provide some guarantee, which is basically taking money and give that to the master chain. So you guarantees with this money that what you do on your parachain is correct, and then inside your parachain you can do whatever you want. The problem with this approach is that if you want to do cross parachain transactions, you want to do an application between and the transactions between the chains, then you have a problem. It's slow, and it doesn't scale in that respect. So the scalability of Polkadot is really constrained by the scalability of the chains themselves. So it's like it's just one chain blockchains which put together, okay, with some kind of guarantee in the middle, just to be very kind of high level. You have another approach which is not sharded approaches, which it's like Solana, Algorand, several others, but Solana is really taking that into extreme. What they do is that they create one chain, but this chain is really, really fast. So they have a 0.4 currently, 0.4, 0.5 seconds block time producing, and it's achieved by extensively using GPU, and they do something. Basically, they take time and they divide this time by very small slots, and in each of the slot you can produce a block. Only certain node that can produce the block inside this slot. So they have they put the order of all the validators, all the nodes, and they try, and because they have this order, they can predict when someone will be the next, and they optimize the whole blockchain to work in a way that every validator will produce the block inside certain amount of time, and that and for this node it will not happen very often. It will happen once in a certain amount of time blocks. So in this way, they do something which is very similar to what, because actually Anatoly Yakovenko came from the background of the Qualcomm, they do something similar to what are wireless networks doing in something called time division multiplexing. And another approach is what Near protocol, and what we're doing in Freeton is to have it a sharded blockchain, meaning several chains, but working in a concert in a way that they all submit the blocks to the master chain, but in between these chains or smaller chains, there is an instant communication. Okay, just let's put it in, again, very high level. Freeton takes that to the extreme. And the difference between Freeton and all these other networks is that not only it is sharded, it is also actually multi-threaded. If you know what multi-threading, so the sharding is, I think previously was said that the sharding is in the database is sharding the data. So you take a subset of data and give it to one node, in this respect, several nodes to run, and then another shard. But sharding the data doesn't really solve the throughput problem, because in databases is done because you have a very large data, so it's very hard to manipulate this data. But in blockchain, you're not manipulating all the data backwards. So it's kind of solving wrong problem, because we actually don't have problem with data. The disk capacities are growing and they're becoming faster and faster. You have today NVMe SSD disks of the, several gigabytes. It's not a problem to store the data. What is really a problem is to execute smart contracts fast. When you think about that, you have maybe hundreds of thousands of smart contracts to execute simultaneously. Sharding the data won't help you. What you will need is sharding the execution, sharding the processing time. And sharding the processing time, called multi-threading in computing science. So what Freeton is doing, and that's a first in the world who is doing that, it's actually inside one shard. You can have many shards, you can have several shards, of course, but inside one shard, it's sharding, it's multi-threading the execution of smart contracts. So what happens is that you have, say, 1,000 validators inside one shard, and then you have segments of these validators who are rotating every 4 minutes, executing one thread of the smart contracts and supplying the proof of this execution to the master chain. That way, we can actually parallelize the execution of as many smart contracts as we want, basically. Just basically, the limit is the size of the validator set, right? So this blockchain has been done by Telegram. Wrote this piece in the right corner, which is the basically C++ execution of this multi-threaded, sharded, let's call it a processor, because if we think about blockchain as a distributed computer, right, as one like world computer, as Ethereum once called it, then we really think about the execution part of this computer as a just distributed processor, correct? So what we have in Freeton is this multi-threaded processor, distributed. Now, Ton.live has implemented the Rust variant of this protocol. So we have this validator node that is written in Rust. And on top of that, we have developed something we call Ton operating system. Now, we call it Ton operating system precisely because we regard the blockchain as a multi-threaded processor. Once you have a multi-threaded processor, or any processor for that matter, in order for the user to start operating on it, you need what it's usually called in computer science an operating system. And so operating system is everything in between the processor and the user application. So Ton operating system is a vertically integrated stack of technologies which sits on top of this distributed processor. So of course it supports multi-threading. It has a Ton virtual machine, which is the computing platform, something that executes actual smart contracts, executes instructions. It has, validator, collator, everything like network protocols, consensus protocols, all that, which basically and resources of this processor. And then on top of this, you have something we call a middleware, usually called middleware in operating system design. So these are compilers, SDKs, and a toolchain for developers to actually being able to develop applications. And Katya and Boris will talk about exactly this part for you in a little later. On top of that, we have written a lot of smart contracts, which are actually like building blocks for the whole network. We call it system smart contracts. And this includes the smart contracts that manages the validators, which is called the lector, that are distributed pools for staking, so everyone can stake. And Freeton, by the way, it's not a delegated network, so there is no delegation in Freeton. You stake your tokens either by becoming a real validator or by staking into the decentralized pools called dpools. But you vote, if you want to vote with these tokens, you will be you're able to vote with them, and not your validator holding them like in pretty much every other network. Like if you want to, if you have a small amount of tokens and you want to stake these tokens in Ethereum 2.0 or in Polkadot or in any other proof of stake networks, you will go to large validator and you will give them your tokens and they will stake it for you. We don't do that. We don't like that because this is a centralization point and you actually giving up your tokens, and we can see that as a dangerous potential attack on the network, because if someone will accumulate a lot of other people's tokens and can vote with them, then you know that's a centralization of power. So in decentralized pools, decentralized pool is just a smart contract. You can stake your token in it, nobody controls it, and you can take it back whenever you want. There is a tokenized contract, and why I want to spend 1 minute on this contract is because the unique architecture, which I'm sure Boris will talk more about, unique architecture of Freeton blockchain is that because of how, first of all, it's like in other blockchains, you have two kind of layers. You have an address, which inside this address is like your wallet address. You can put tokens in this wallet address, like in Bitcoin, for example, or in Ethereum. In Bitcoin, you have a UTXO, of course, but let's say in Ethereum, where you have an accounting, like account-based blockchain, you just calculate your address. You can actually send tokens to this address. And then you have smart contracts, which are separate entities. In Freeton, it's the same thing. So you have account, and you can actually send tokens to that, but you will be able to use these tokens only if you deploy code there. So if you deploy code there, it means that every account in Ton which is active it's a smart contract. So it's like making it the largest smart contract platform, maybe even the ultimate smart contract platform, because you cannot do anything without having a smart contract. So because of this nature of this architecture, what we've been able to do is also to create an architecture which makes it of the smart contract, which makes it completely distributed. So for example, in Ethereum, you have something called the ERC20, and there are many other standards built on top of that, which is the tokens on Ethereum network, for example. So how these tokens are done? It's basically a ledger, one smart contract, which holds like a pair of your address and the amount of tokens you have. So if you want to have a token which distributed to millions of people, you will have a smart contract with millions of entries. Now, that creates a problem because to operate, of course, on this smart contract, on this huge pile of data, it's very costly. It's the operation, like the operations you need to perform on this are becoming very heavy. What we came up with is the ability to make the token contract completely distributed. So everyone has their own contract and there is no ledger, but yet there is a proof and guarantee that the token that you hold in your wallet is actually, you cannot double spend. It's very interesting. I suggest everyone to read. It's called Tip 3. And there are actually, on top of that, we built a lot of other use cases for this token. For example, a distributed domain name or name system in Ton called Tip 2. It's also very similar to that. We don't need to, in order to have a domain name in Freeton, you don't need to have a smart contract which holds all the domains. Okay, so basically we have this layer of smart contracts, which we have developed, and now community start to develop a lot on top of that. And I hope you will be able to do so as well. And then on top of that, we created something called DeBots. DeBots is decentralized bots. And DeBots is created because we thought Web3 architecture sucks. And let me spend 1 minute on how Web3 works. And of course, you know what Web3, right, is. So Web3 is a library, basically, which enables your front-end application to talk to the blockchain. So if you have a website, for example, and you have a button which want to read something from the blockchain or write something to the blockchain, you connect the Web3 library to this button, basically, and it performs certain function. Or to perform this function, it calls your wallet, which, for example, a MetaMask, and then through this interaction between this MetaMask, between the website and between the Web3, you kind of can create a transaction and send it out. Why it is bad? It is bad because, first of all, it's very complicated for the user. And second of all, because it's actually a centralized architecture again. Why it is centralized? Well, because you put Web3 library somewhere, so you need to have a website. Now, if you have a website, you have a server. And if you have a server, you have a centralized point. Now, so what is the point of having a blockchain which is a decentralized and censorship resistant and all of that, right? Trustless and everything, and having a one website which you interact through with this blockchain, which this website can be controlled by someone, can be censored by someone, can be, and so on, the data can mutate and so on and so forth. Web3 is trying to get around that by introducing like IPFS websites. So you hold your site on IPFS kind of storage, and then you downloaded it together with Web3 and all that. And that's kind of to get around the problem of centralization of the Web3 architecture. But it's very similar to how Ethereum tries to solve their problem with scalability by introducing side chains. It's not very feasible, like in real life. Side chains are creating problems because of the side chains need to submit the data to the blockchain. It takes a lot of time to synchronize that. Also, you have a problem of trust of this particular side chain because it's not you trust the Ethereum network with billions of tokens, their value, but why should you trust the side chain? And so on and so forth. What we have created something called end-to-end decentralization and E2ED. An E2ED concept is where everything is happening in trustless manner from the user interface without introduction of any centralized entity whatsoever. So what is DeBots? DeBots are also smart contracts, but instead of being executed, they are stored on the blockchain, but instead of being executed on the blockchain, they actually executed in SDK, something that Katya will talk about. The SDK is a thing that runs inside your computer, and it has also virtual machine, Ton virtual machine, and you can execute the smart contract on your machine, inside your virtual machine. And this smart contract will actually act like a bot in a chat. And this bot will interact for you with any smart contract which runs on chain. So with DeBots, you have a very easy way. If you write your smart contract and then you write a DeBot for this smart contract, you have a decentralized interface that any user can now operate with your smart contract through just interaction with this bot. So for example, like if you want to create a wallet or multi-signature wallet, you just call this DeBot on your machine. It will be downloaded from blockchain through the node. You verify that it's verified that it's indeed the same as on the blockchain smart contract. And then you run it inside your virtual machine and will start talking to you, ask you questions. You can ask, you can try it yourself. By the way, it's very easy. Start asking you questions like about what kind of parameters of the wallet you want to create. It will create the message for this and send it without your even realizing that, send it to the blockchain, and your wallet will be created, so on and so forth. So these are kind of a user bots. And of course, you can create any kind of interface on top of that, and to interact with these DeBots. And the interface for this we call blockchain browser, because it's really like a browser of the web, where instead of HTML page, we show to the user the DeBot. Now you can create any kind of interface on top of that. If you want, you can create buttons, or you can put it in the conversation kind of style. But in the end, it's something that runs inside your local machine as a browser, interacts with the DeBot, basically showing the DeBot actions to the user, and allowing him to communicate with that, and then sending it to the blockchain through the SDK, all in completely decentralized way. So one of the browsers we built in Ton Labs called Ton.Surf. Of course, I know many of you maybe already downloaded that, so you can interact there with the blockchain, sending transactions to each other and so on. There is also another thing that we're building. It's called Ton Card, and Ton Card it actually will be released, I think, this week to the developers. It's a secure enclave, just an NFC card basically. It has one Infineon chip inside of that, and this chip generates the private key inside the chip and never gives it out, so you cannot extract it. So this card can be used to be your kind of one of the signatures of your multi-signature wallet, for example, or it can be used as a cash card. Actually, you can load the cash inside the card. We can load the tokens inside the card and just give it to someone. And because this card does not ever reveal the private key, the person who you give the card is very sure that you cannot spend the same tokens twice. So when you give this card, you give the tokens basically. So there are many other use cases that you can do with this card. For example, it can be used in like a guarantee. For example, for transaction, you can give a card as a one signature and leave a sum like escrow, and so on. And of course, you can secure your own account with that, because you can have several of these cards as signatures to your multi-wallet account if you hold a lot of tokens. Well, I think that's kind of an overview of the architecture that Ton Labs is building. It's what we wanted to do for the developers. The idea is to have a system where you can create your applications as easy as you would write an application on, for example, the Firebase. So instead of going and assembling your technology stack from different places like you would do in Ethereum, where you have a truffle, then you have somewhere else the debugger, then you have a Web3, which is the application, then you need to build the backend. On this backend, you need to build a database so that the database will download data from the blockchain for your users, and then send it to your user's application. And for that, you need several developers to do all that. We wanted to abstract all that for you, like Firebase did for mobile developers. So you don't need to actually think about any of that. What you need to do is just concentrate on your application and developing your smart contract, your DeBot, and your front-end application you don't even actually need a back-end developer. And you can use the SDK to communicate with the data on the blockchain just by installing the SDK. You don't need anything else. There is a cloud that runs for you. And this cloud currently runs by Ton Labs, but it will be, there is a sub-governance in Freeton, which now creates a standard for how to decentralize that whole infrastructure. So there will be a lot of people who will run this cloud for you. And what you need to do is just to put an address in the SDK, and it will connect to this cloud without you even thinking about that. Now, all the data is put already inside the database, and SDK is communicating with the GraphQL through the GraphQL protocol with this database. Now you inside your application can create like a GraphQL queries, and if you and show the data to the user. It's all there. You can filter it the way you want without you need to think about this infrastructure. So we do all this hosting, and if you really compare it to, I don't know how many of you develop ever on Firebase, but you compare it to Firebase, like you think about smart contracts as a functions on top of database. You have a database, you have a functions on top of database, and then you have an SDK which supports many languages. By SDK, Katya will talk about that, supports now, I think, over 20 platforms. And you manipulate with this data, basically, and that's everything you need. In fact, you don't even need to create a front end. If you just create a smart contract and the DeBot, then like any Freeton browser will be able to operate with this DeBots and will show it to users. So for example, Surf. All you need is just to give up to your users your name in Freeton, the address of your DeBot, and that's it. Nothing else. Thank you very much, guys, and see you around. Let's handle it to Boris and Katya for the next part.
Okay. When I was preparing for this call, I thought about the easiest way for you to help you quickly get started with Freeton. So I came up with some quick start guide, and we will briefly go through it now. So the first thing at this point that I encourage you to do actually is to go to test.org page and find these specs here, Ton, TVM, and Ton blockchain. And they're pretty big, about 150 pages, but I encourage you to read at least 30 pages of each of them to understand what is actually going on here right now, because we are in the stage of pretty low level development right now. I hope we will finally come to some Firebase-like thing where it's possible to somehow abstract all of this from you, but now these things are essential for you to understand actually what is happening here. So for this presentation, I also prepared some basics of Freeton blockchain for you to understand the further things that I will talk about. And I think that this page is public. I will send it now to Zoom, or maybe later. Okay, I will send it in the end of my presentation. I don't know how to do it right now. So, okay, let's go through the basics of Ton blockchain. Very, very basics, like in 3 words. This is essential for you to understand all of the further information I will talk about. So at the moment, Freeton blockchain has 2 workchains, Masterchain with the ID of -1 and simple workchain with 0 ID. So the Masterchain is used for service contracts and the 0 blockchain is used for some simple user wallets. In turn, workchain splits into shards, so-called shard chains. When the load increases and when the load decreases, it merges back. It is validated by some validators. Part of them validate Masterchain, and others are splitted into groups and validate shard chains. Sometimes elections happen that switch the global list of validators, and within one election cycle, shard chain validators also rotate. So the next definition, account. Account is basically an actor in blockchain. It has some properties such as address, balance, And also it has a place to store its code, so-called contract actually, and a place for its data. So it can have one owner, many owners, or no owners at all. And the address of the contract can be calculated from its initial code and data when it is being deployed. I will say a few words about deploy now. It means placing code of the contract into the account, into the blockchain. So the problem with the deploy is that it's not for free like another blockchains. So it's important to understand that before you deploy something, you need to pay for it. So you need to sponsor that address beforehand. A little about money transfer. Mitja already mentioned that it's not possible to transfer money between accounts if you don't have any code. So the transfer is basically executed by the contract code. So do not transfer money to the addresses where you cannot deploy code, because they will stay there like forever. A little about commissions. I just gave you the link to the page where you can read about the commissions, the fees of the blockchain. Shortly, there is a storage commission that is paid for storage of account, and some commissions for message sending between accounts, and of course some commission for execution depending on the code complexity. A little about get methods. What is get method? It's a method of the contract that can be executed locally for free on client side. Another important thing to understand about sharding is that how to find out what shard my account is in right now. So the shard is basically defined by some hex in hex format, and it's basically representing the first bytes of your contract account address. And to find out what shard your account is in right now, you need to like put the shard prefix in binary format on top of your account address in binary format. And if this numbers like merge, then your account is in that shard. You can also read about it here, but I encourage you to go deeply into the specs of Ton as well. So message, what is message? Messages are all interaction in Ton is performed via messages. If you want to deploy your contract, you create a message and send it into the blockchain. If you want to call some contract on blockchain, you also prepare a message and send it into blockchain. When contracts communicate with each other, they send messages from one contract to each other, so-called inner messages. If you want to get some events from contract execution, you listen to the external outbound messages or events of the contract. So you can implement any off-chain logic based on this contract events. So transaction, what is transaction? It's not what it means in Ethereum here. Transaction, we do not send transactions in Ton, we send messages. Transaction is basically the action of contract execution. Transactions are usually, except for some system contracts, are generated by one external inbound or internal message, which means that by one message that comes into the contract. And as a result, it can generate several outcoming messages, both in external or internal. In turn, transactions can be successful or aborted in case there are some errors in contract code, or maybe the balance wasn't enough and fees are too high, and so on. The next very important thing to understand is BOC, bag of cells. Bag of cells is actually, it's just simply a format of data packaging in Python. You can find out more accurate like description of actually the algorithm of this packaging in the specs, but for now I think it's enough for you to know that it's just some packaging format, and every object, account, transaction, message, even and blocks, they all stored in so-called bag of cells. And for example, if you take a bag of cells of a block, it contains bags of cells of transactions and messages that were executed inside of it. Okay, TVM, Ton Virtual Machine. It's a Turing complete virtual machine for contract code execution. It works with bag of cells. This is why you need to understand what it is. And actually, TVM does not calculate any commissions itself. It just runs the contract code and generates some external messages, outcoming messages, and it is used. It can be used locally on client side for get methods execution and DeBot engine Mitja talked about execution. Also, TVM is used on validators, but on validator side, it is used together with higher level protocols. One of them is transaction executor, which additionally calculates commissions and performs other checks to validate the transaction. Well, and the last definition, I will say a few words more about transaction executor. It also can be used locally. SDK uses it for contract debugging, fees calculation, and so on. So it's the same component that is used on the validators, but it can be used also on the client side for debug. So it was the brief overview of Ton blockchain. So now let's go to Ton.live to see all of this actually with your own eyes. Here you can see shard chains, Masterchain, and zero shard chain. Here you can see shards. When the blockchain doesn't have any high load, it has 16 shards. When the load increases, they split. And so let's go to some block, Masterchain block. Here you can see transactions of this block, messages of this block. You can walk through blocks, go to previous one and to the next one. So here are transactions. I don't know, let's check some transaction. Here's the address of the account which the transaction belongs to. Here you can see information about gas, fees, and so on. Let's go to messages. Let's check some, I don't know, let's check this message. So you can, as you can see, it has some child transaction that I told you about, like message generates actually a transaction, and there are no outgoing messages here. It's just only one incoming. Okay, so let's go to accounts. Here you can see some accounts. Let's open some account. Here you can see its address, its balance. If you click more details, you can see its code, code hash, data hash, and validators. Here you can see information about elections, but for this thing, I encourage you again to go to specs and read about elections there for more details. So, okay, so what's next in my quick start guide? The next thing you should do now, at this stage, is to understand how to create your first smart contract. Boris will tell you how to do it after me, and you need to learn how to compile it and how to get your TVC and ABI files. After you are like created your first smart contract and you understand how to do that, now we can go and review all the possible use cases you can implement with SDK. Just follow this link. So let's go and see. You can deploy smart contracts. You can send external messages to smart contracts. You can run get methods. You can run DeBot engine, Mitja just told you about. You can debug your contracts locally. Also, you can query blockchain data, subscribe to blockchain updates, including contract events, and not only them. You can monitor message delivery. It's a separate complex topic about blockchain. Some messages, sometimes external messages are not delivered, and it is possible for this blockchain. It's described in Ton spec. So you need to understand this process of message delivery. Also, you can decode and encode ABI compatible messages to actually decode the information from contract event, for example. You can estimate fees. You can also, there's a crypto module where you can generate keys, generate mnemonics, and encrypt, decrypt data, calculate hashes. Also, we have a complex network layer where we provide some functionality to suspend or resume WebSockets, and SDK can work both via WebSockets and fetch. So, and also important thing about cryptographic module is that although SDK provides all of these functions to encrypt, decrypt, and sign and stuff like that, if you're having some wallet where you operate with some big sums of money, we encourage you actually to use external signing for that cases, and SDK provides some support of such an interface called signing box, where you can implement integration with your signing device, such as HSM and NFC, or maybe some secure storage on your device, and to sign your messages outside SDK, and then just put the signature into. So this is also possible with SDK. So you can use your external devices for signing without private key disclosure to your application and to SDK. So, okay, this this was the overview of SDK use cases. Now, after you read all of this, you can go to quick start. Actually, it's here. You just need to read all of this. You need to have these prerequisites, Docker, Node.js latest version, and also we prepared for you already compiled contract. Hello, it's a simple contract that has like only constructor and just two methods. One method is a get method and another one is a simple method. And then you need to go through all of this instruction to, you start local node, you create this Node.js application, you configure your client to connect to the local node, you integrate your contract artifacts into the project. So you can see you connect its ABI and its code here. And then you deploy, you sponsor it with Giver. As I said, you need to sponsor your contract before deploying. Then you run some get methods of this contract. No, not even just a method and then get method. So I already have, and also you can find this project here. In the beginning, you have a link to the full example. Here it is. I showed you already. So I already have it installed. And I will just show you now how to run it. Okay, so here's the code. So before we deploy contract, we calculate its future address from keys, and yeah, here we only use keys because we don't have any initial data in this contract. Then we use a local node giver to sponsor it with some tokens. Here you can see this step. Then we deploy, actually. And then we run this. Oh, sorry, I can wait a second. This one. Here's this one simple. So yeah, here we have this. We generate keys. We calculate. We encode deploy message. Then we calculate the future address, and then we sponsor it. Get grams from giver. You can go through all of the comments here in the sample to understand what is going on here. So then we create a message to call our function touch. Then we call it with process message function. And after that, we execute get method with run TVM and get our timestamp from the contract. So this is it. This is the like hello world project on JavaScript. Okay, let's go next. So now let's open ABI file and see how it connects with our message creation. Let's open. So here's ABI file. It's actually the interface of the contract. You can see the methods of the contract, and let's go to, for example, to the get method timestamp, get timestamp. Yeah, you can see in code message, we provide ABI address of the already deployed contract, and we define function name times timestamp. And we do not sign this message because this contract do not require any signing, any keys. So we create this message and then we execute this run TVM. We also provide ABI here because we need to decode the result with this ABI. It uses these values to decode, and then we receive the result in this decode output field. So this is just for you to understand how ABI and message creation are interconnected. Okay, let's go next. Yeah, to get further understanding of SDK most common use cases, go to the documentation. Here you can see these common use cases with contracts. For example, how to, in more details, how to add your contract to your application, how to deploy contract, run contract. About external signing, I talked about how to connect with some external devices for signing. Also, you can read about message delivery here, which I mentioned before, that there are some situations where messages are not delivered. To understand how to resolve these issues, go and read these articles. Yeah, so there is a lot of information actually. Okay, so what's next? Now I think it's time for us to explore GraphQL API. Documentation is here, and we will check out the API of our local node and then some mainnet or DevNet API. So what is GraphQL API? GraphQL API is actually the blockchain API SDK works on. It allows to query data from blockchain, parsed data, and send messages to blockchain, which are created on the client side, and subscribe to blockchain data updates and event contract events. So go to this samples section, and here you can see the samples most used and samples that were asked by community. For example, let's go to mainnet and get our blockchain config. Okay, so to understand actually what is going on here, again, you need to read specs. But in few words, I just got the config of the blockchain of the current at the current moment, so I can see the information about elections here. I can see the current validator set here. You can see these validators with their public keys and DNL addresses. And here are some other config values like maximum number of validators, minimum number of validators, min stake, max stake, and so on, and timing for elections and so on. It's just one example. So you can go through all of these samples. And to get, after you read the specs, you will get better understanding of the blockchain. What actually is this config? What are these shards and so on? Yes, so let's go and see the results of our execution of our hello application on the local node. Here you see, you can find the step here. I added this queries here. You can use them to run on your computer. So, for example, here's the query of the account that I deployed. Here's its ID, workchain, last transaction, logical time. Again, read specs about this parameter. Balance, block encoded in base 64, and code hash and data. There are also other fields. You can check the API, you can check the data scheme of the GraphQL API here. Click Docs button, and you will get this self-documented schema. You can see some definitions here. So it's basically self-documented. You can go and just look at all the fields of the account, of transaction, like total fees and incoming message ID, fields of blocks. So Masterchain block, for example, has a master field, and Sharding blocks have master field empty. What else? You can check info query, which will give you the version of the GraphQL server running at the moment. You can also get some aggregations here. You can count number of blocks, filtering them by some condition. Or here you can see all the possible filtering options here. And aggregate other things like, I don't know, number of transaction of account, or number of messages, or number of messages between some accounts, and so on. All of these samples you can find in the samples documentation. Okay, so here let's go to the transactions that were generated during our execution of Hello project. Here you can see 3 transactions to this address. So here you can see messages. This is the deploy message, actually one, big one with provided block of the contract for deploy and data. So, okay, so what's next? We read about local node documentation. Oops. Okay. It's here. I also left some link there. So here you can find the installation guide. If you have some problems, go and read here. Also, here's information about giver, its ABI, its address, and its Solidity code even. Also, please take a moment to read about differences in behavior of local node comparing with real blockchain. It has some differences that are very important to understand. For example, it doesn't have any master chain now. It doesn't generate empty blocks and stuff like that. So the next thing you should do for further exploration of SDK is to check API reference. At the moment, our API reference is situated here in our core SDK repository. Here you can see a description of all modules, functions, and you can go to some function, for example, in code message, and see the parameters description and the function description, then parameter descriptions, and some parameter types descriptions as well. And these code snippets of function signatures in TypeScript and type signatures in TypeScript. The last thing I want to talk about is architecture of SDK. You can go to our core repository Ton SDK and read about it in README. But basically, in 3 words, we wrote our core library in Rust and created thing bindings over it in TypeScript. And also community created several bindings in other languages. You can also find it here, find them here. It's like 14 languages overall. PHP, Python, Swift, and .NET. So you can even create your own binding if you want in your language. There are instructions how to do that. There are instructions of the JSON interface that is used to connect thing binding with this core library. So a lot of information. If you're interested, just go to the Ton SDK repository. And this small thing I added in the end is just, I don't know, for overall understanding, you can go to this file and read about smart contract addresses formats, that raw format exists, and some bounceable, non-bounceable addresses, but it's not the most important thing to read, but it's pretty useful. And also you can get this overview of account structure here. Maybe it will also help you to understand what is bag of sales is and of account, and make it easier for you to understand the message creation in SDK. So I think this is all I wanted to say. I hope the link to this guide will be provided somewhere below the record of this call. So thank you. If you have any questions, please ask, or you can also join our Telegram channel. You can find the link here. So there's a lot, like 200 developers there, and you can get any help very quickly in that channel. Okay, so thank you.
Hi there. Thank you, Katya, for a great overview of how Ton blockchain can be used. I was going to how smart contracts are created, how they're designed, what are the rules, but instead I decided to show you how it's done. So in a few words, smart contracts are the programs which work on blockchain and have persistent data. That's basically all the theory about smart contracts. The rest are related to implementation. So there are pages for the developers which describe basic process. You can write in Solidity, you can write in C++, but the main aspect is that you should know how blockchain works well to code for it. There are samples. many contracts, so wallets, casinos, banks, piggy banks, etc. There are contracts which work for the community. For example, let's see, that's governance page, which hosts all the contests which are held for free now. You see, there's a lot of them. So starting from this and all the way up, all the contests are held served by a special smart contract, which accounts for all the submissions, all the jury's work, evaluating and storing their comments on blockchain. That's the only known to me real contest held on blockchain, not just storing data, but taking care of all the process. The contract which facilitates this is open source. So you can see it. It's not really that big, but it actually takes care for all the stages of the contest. So it must be very complex and really difficult to work with this contract, right? Well, not really. Let's take a look at how it's done. Okay, we have a source code editor. There is how the smart contract code looks like. You see that's the same code. So we can compile it using some scripts. So it compiles the code of the contract and then puts the code into the data of another smart contract, which serves as an on-chain deployer, which helps to set up the contest, set a set of juries who will be working on it. And so basically what do we do here? We compile the code, link it into the binary form, which doesn't look really understandable, but that's how it looks. Then deploy this contract on the blockchain, and then we can watch it on the web in the same Ton.live as you had seen before, right? There is a contract, there is its code, its data, which is basically the code of another contract, which we have just loaded into it. And that's combined code and data. You can see messages we have sent to the contract, setting a jury. So let's set up a jury for it. Basically, it takes a fake set of keys and set of addresses and pretends it is a real jury to help test the contract. Okay, we have set of juries, keys, and addresses, and then we simulate a creation of new contest with the parameters we have set, right? Setting its title, link to the form, hash, start date, end date, etc., rewards, number of juries. Is it the same data? It's actually why it's taking so long. It loads all the data in the blockchain for us to view. So later we can check if there is a data. See, there is a data which we have just deployed, right? That's the code. That's the versions. That's set of juries. And encoded are also the numerical parameters for the contest to deploy. So, okay. That's the contest we have deployed in the blockchain. So another contract, right? It's the contest itself. We can check if it has deployed successfully. Basically, it tells everything about itself. Information, set of juries, which are read from that contest already. Timeline, when it starts, when it ends, when voting starts, stages of the contest, rewards, which are due, to the participants at the end of the contest, and the information about the current stage of the contest. Basically, this is a simulation of the same process which is used to govern all the Triton contests, and that's how tokens currently are distributed to the community. And basically, that's as simple to deploy rather complex, useful, and real production contract. So it's great to develop on Triton as a platform because it offers you unique debugging capabilities. You can check every transaction, every message, and you can check all the information about it. Why it succeeded? For example, you see that aborted is true. There is a reason, and that's guess limit, guess used. Okay, we are in the limit. Exit code is 51, and I know that the constructor was already called. That's all right because we have tried to deploy the same contract on the same address, which is basically harmless. And that's how we can oversee all the operations of this contract, and we can always pinpoint all the divergences from the way we wanted it to behave. And that makes programming on blockchain also very much fun and very rewarding and satisfying. So basically that's it in a nutshell. That's how smart contracts work on Triton. It's very, very different from how other blockchain works. So if you have any previous blockchain knowledge about Ethereum or other blockchains, you'd better start anew. And all I can see is that writing smart contracts for Triton is like, for me, it's a great hobby. I do it just for fun. So if you have any questions, please direct it to me. I will be happy to answer.